So let's dive right in and talk about what we want to talk about today, and that is OIDC support in Oracle Kubernetes. So before we dive too deep into it, let's discuss, well, what is OIDC? So at its core, OIDC is an open standard authentication protocol. So it is built on top of OAuth 2. OAuth 2 itself is mainly concerned with the field of authorization. However, it does not handle authentication very well, if at all. Um, in the OAuth 2.0 framework, OIDC came in to sort of address that that fundamental problem and add support for authentication on top of authorization. Now, why use OpenID Connect? So in the world where, we're seeing increasing usage of, say, multi-cloud, where you have resources in Azure, resources in AWS, resources in OCI, it's becoming more important to couple these together, especially in the field of, authentication and authorization. So, um, before the world of, OIDC and OAuth, you would have to configure credentials for every application. However, with OpenID Connect, we can now standardize these, and you can use a single set of credentials for multiple applications. Think, single sign-on. Now, once we bring this to Kubernetes, we, have to ask ourselves, well, what can OpenID Connect do to help us in Kubernetes? Well, there are two fields where this is very important, or two features, I should say. There's OIDC authentication and OIDC discovery. So, OIDC authentication is the idea that I want to authenticate users that are present in a existing OpenID provider. So I don't want to use a different set of credentials. I want to use an already existing set. And when I go to authenticate to a Kubernetes cluster, I want it to use those credentials instead. OIDC discovery, on the other hand, is mainly focused with using or uh, authorizing access to third-party resources um, to service accounts in Kubernetes. So we'll go more into that in the next slide. How does authorization authentication work in OKE today? So, as you probably know, if you use OKE, the way authentication works is that you have an OCI user. So, um, so here you're a user that's part of a IAM group, and you have credentials associated with that user. These credentials are the API, the API keys, and then some associated information to those API keys, things like the fingerprint, um, the region, and so on. All of this information makes up your credentials for OKE. And when you go to run a kubectl command in your kube config, you have all of this information configured. And that's what's used when you make a kubectl call. It uses that key to um, authorize access to OKE. Of course, once you actually access the control plane, we do integrate with cluster roles and cluster role bindings such that you use Kubernetes RBAC to authorize specific operations on your users and your groups. Optionally, as many people do, you can also federate this with a third-party identity system, uh, a third-party IDP, which will federate with OCI IAM, but ultimately your users are fundamentally OCI users, right? The only exception to this rule is if you want to use Kubernetes service accounts instead. Then that sort of bypasses um, uh, identity and access management. However, if you have a real user, you don't want to use service accounts for real users most of the time. Let's go into OIDC discovery. So this is a sequence diagram that shows the flow of um, discovery. When you create a pod in Kubernetes, that pod has a service account token mounted onto it. That token is associated with a service account, either the default service account or a service account of your choosing. Well, let's say that that application needs to access a resource in a third-party resource. So it could be another cloud, for instance. Well, in the past, what you would have to do is set up the credentials on that pod to access those third-party resources. OIDC discovery helps address this issue because we don't always want to put credentials on these or mount credentials on these pods. Why not just use the surface account token that the pod is given? What you can do with OIDC discovery is you can exchange the token that's mounted on the pod with a token granted by a third-party issuer. In this case, it could be AWS, for instance, it could be HashiCorp Vault, any third-party service that can issue tokens. All you have to do is give it the what's called the issuer URL, where the token service then requests a key from OKE and then validates the token that you send it. At the end, it will grant you an access token, and that token is then used from then on to authorize access to third-party resources. This is great because you don't need to configure credentials on those pods. You can access it using OpenID Connect. So I just want to go straight into some demos that highlight both OpenID discovery and OpenID authentication. So the first demo I want to show is connecting to OKE through GitHub Actions. The second one I will show is authenticating Keycloak users in OKE. And the last one I'll show is accessing HashiCorp Vault using Kubernetes service account tokens. So for the first one that I'll show, connecting to OK through GitHub Actions, this is just a basic architecture diagram showcasing what I will show you in just a second. So it's very common to have a use case where you may want to use GitHub Actions as a CI/CD tool. Now, if you've tried this in the past, you'll know that for OKE, there were two options. In GitHub Actions, you either had to configure your OCI user's credentials. You had to either create an OCI service account and configure its credentials, or you had to create a Kubernetes service account token. In all of these cases, these are considered long-lived credentials. So they last for a long time, and you have to rotate those credentials periodically. Now, what's different with OIDC? With OIDC, we can issue a token on GitHub Actions and then establish a trust relationship with our OKE control plane where it will trust the tokens issued by GitHub Actions. And these are short-lived tokens. So they will expire after a short amount of time. And once that happens, you just issue another token. So in this demo, I'll show you how to set that up. But the general workflow is, you generate a token through GitHub Actions. You send that token to the API server for Kubernetes. Kubernetes then validates that token that you give it, and then you can make calls to the control plane after that. And then you map that user that's associated with the token through Kubernetes RBAC. All right. So let's go ahead and have some fun. Let me share. Perfect. All right. So let's create a new repository. If this will be nice. So let's give the repository a name. I'll just call it Cloud Coaching OIDC Demo. And I'll just create this just all basic, nothing too fancy here. Create the repository. Now I have a repository. I'm going to go ahead and just create the action. I'm going to create my own workflow. And then I will actually go and copy an action I have, but then walk through what the action does. So I just pasted an action, but I'll walk through exactly what it does. So I'm calling it OK OIDC. Every time I push something to the main branch, it should execute this action or a pull request. A requirement is you do need to allow write access so we can receive OIDC tokens from GitHub. But the actual where the magic happens here is this step right here, create OIDC token. So we need a few pieces of information here. The audience, this audience can be whatever you want it to be. In my case, I'll just keep it as OKE Kubernetes cluster. And then when I go to fetch the token, I need to provide that audience. And then I actually run a curl command here that curls the GitHub Actions token issuer and retrieves an ID token. I will be using this ID token to authorize requests or authenticate requests to the Kubernetes control plane. So that's pretty much it for that step. The next step is just check the permissions in Kubernetes. So in Kubernetes or with kubectl, I have this flag token where I output the token that I retrieved from the previous step in here. I specify the server that I want to use. Actually, let me do that now. Let me find so I will give it the public URL for my Kubernetes server, and that is it. So actually, before I commit this, I also need to configure on the OKE side the control plane so that it will accept tokens issued by GitHub Actions. So how do you do that? We have to provide some JSON and then send this JSON to the control plane through the OCI CLI. The fields that I have configured here is that. So is OpenID Connect auth enabled? Of course, true. What is the client ID? This client ID should match the audience from the GitHub Actions workflow. What is the issuer URL? The issuer URL is that comes from GitHub Actions. What is the username claim? That should be sub. What is the prefix of the username? Now you can set this to whatever you'd like, but it's a good practice to set this so you don't muddy users that come from different sources. And then this one's important. So the required claims, what claims should be present in the token? Here I'm setting the repository. So repository equals the name of my user slash the name of my repository. So I do need to change this slightly because I created a new repository called slash cloud coaching OIDC demo. And what workflow does this come from? What is the name of the action itself? I named it OKE-OIDC. So that's what I refer to this as. And then the branch, right? So after you do this, you can run an OCI CLI command where you have to provide a few bits of information. The cluster ID, then the JSON file. So I'll do dash dash options should be from JSON, and then I give the path to uh, this file, which I should have it somewhere else. Jay made one mistake. Remove that. Then I'll paste this, and then I apply that. So it will take a few minutes for this to be reflected on the control plane. But before long, it will end up working. So once you run that, it will give you a work request ID. You can go onto the OCI console and check this um, check this work request to see if it has succeeded. All right, so let me actually I can go on to the OCI console if I have it up.
While we wait, there's a couple questions maybe we can
Oh,
answer
sure,
in the Q&A.
absolutely.
Um, there's one about how many clients or tokens could be registered for a single OKE.
Let me see. Let me pull up the chat
Yeah.
or the Q&A.
So, yeah, there's that one, and then one about the Actions ID token request, where it was coming from as well, and how it's set in OIDC.
Where's actions? Oh, okay. So, yeah, I see the actions ID. Yeah, so that it does come from GitHub, the action itself. Um, that's where we got it from. The how many clients slash tokens could be registered for a single OKE. So there is right now you can only register one unique issuer. As far as the limits to the amount of tokens that can be registered, um, I don't know on offhand right now. And I have it in this cluster. Then we can see the work requests here that then show that it's completed. So once that fetches, yep, there we go. So that's been completed. Now I'm going to create this action and have it run. I'm just going to create a basic commit, and then this should run automatically. So there are a few steps here. One is to get the token, and one is to run the actual check permissions. So you can see this step, I retrieve the token, and this step is just to verify that my user is authenticated to Kubernetes. And you can see that is the case. One thing I actually neglected to show you, I apologize, is the actual um, RBAC piece. So how do you configure the roles and the role binding for this? So I have a role that's called Actions OIDC role, and I just give it some very generic permissions. And then the role binding is where this is important because this is where you actually bind the token that you retrieve from GitHub Actions to a user in Kubernetes. So under subjects, you can see I have kind user and then the name of that user. This name comes from the claim, the sub claim, the subject claim of uh, that token, and it matches this. If I were to put that into .io, you would see that it would be repo Matthew McDaniel slash cloud coaching OIDC. So that's it for the first demo. That's just to show how you can use GitHub Actions to authenticate to OK. Keep in mind, in the past, you would have to manually configure credentials, or you would have to create a Kubernetes service account token. Both are long-lived. So this is definitely a great improvement to that workflow, where you can now use GitHub Actions and GitHub Actions as an OIDC provider to authenticate to OKE and automate your workflows. Before I move on to the next demo, are there any questions, uh, any pending questions for this?
I don't think we have any open yet.
Okay. All right, so now I'll go back to the slide. Okay, so we just executed this. Now let's go on to another use case, which is also OIDC authentication, but is is different in its nature. So the last demo was focused more on a CI/CD use case using GitHub Actions. But how about you want to bring your own identity provider and not federate that with OCI? This demo will show you how to authenticate Keycloak users in OKE. So Keycloak uh, is an identity provider that you can use, and it is also an OIDC provider that you can use to author or authenticate Kubernetes users. So the general workflow here is that I have Keycloak running in a Kubernetes cluster. The user will log in to Keycloak. Keycloak will return an identity token and a refresh token to the user. The user will then use this token to modify their kube config and then use that token to access the Kubernetes cluster. And then just like what we did with GitHub Actions, we set up role bindings to identify and authorize that user. All right, so how do we do this? I will show you in Keycloak how you can do this. Okay, so I'm in Keycloak. Keycloak has a concept of realms, so different sort of configurations and different domains for Keycloak users. I already have a couple of realms, but for this scenario, I want to create a brand new realm. This realm I'll just call Cloud Coaching OIDC, and then I will create it. Now, in Keycloak, we have to create four distinct things: a client scope, a user, and a group that that user will be associated with. So we'll start with the client itself. This will be a confidential client where um, you can give it any client ID you would like. In my case, I'll just call it OKE Kubernetes cluster, and then I'll just keep everything default. I will enable client authentication so that clients will need the client ID and the client secret to be granted a token from Keycloak. I'm going to keep everything default just for the sake of time. Okay, so now that the client's created, I will need to store this client secret and the client ID. So I will store this on my side and then the client ID, which is just the name of the client. All right, now that the client's created, I need to create a client scope. Now, I could just use one of these basic default scopes that Keycloak provides. However, I want to map this user, or I want to use this users group to authorize access to Kubernetes. So what I will do is create a separate scope, which I will call groups. I will set this as default. I will include it in the token scope. And I will map this, wrong one. I'll configure a mapper to map the user's group membership to the scope. I will call this groups. Then I'll add it to the lightweight access token. All right, now that the client and the client scope is created, actually I need to go back into the client and add that scope. So I will do that. You'll see here, there's the scope that I created. I will add that to the client. Great. So now I have the um, client and client scope created. So now let's create a user. I'm not going to set any required user actions, nor will I require them to verify their email. I will just give them an example username. Guess I'll call it Cloud Coaching OIDC. And I'll leave everything else blank. You could do all this as well if you wanted to. Now that I have the user, I need to create the group. So let's create a group. I'm going to call the group just devs. It could be anything you wanted it to be. And then go into the user and assign this user to that group. The reason why I'm creating groups is because when I create my role binding in Kubernetes, I want to map um, roles to this particular group membership. Okay, now that I have a user and my client is created, my client scopes are created, I need to now generate a token for this user to then modify my kube config. Now, how do I do that? So in order to do that, we will use kubectl config set credentials, and we'll create a new context for for this particular user. So I will call it Cloud Coaching OIDC. The auth provider is OIDC. The issuer URL, I will need to change this to the issuer of that particular Keycloak realm that I created. I called it Cloud Coaching OIDC, I believe. Did I do that? Yes, I did. The client ID, which is just Cloud Coaching OIDC, and then the client secret refresh token, an ID token. Now I actually haven't gotten the ID token nor refresh token because I haven't actually authenticated to Keycloak yet. So I just realized I skipped that step. So let me go ahead and generate that. I'm doing this off screen so you can't see the client secret, but what I'll do is go back and get the client secret that I will need to use. All right, actually, one more thing just realized I forgot to do was assign a password to this user that they will use to get the token. Let me do that. All right, there we go. Thank you very much for your patience, everyone. I apologize for that delay. Let me show this again. So once I've authenticated to Keycloak with that user, I am given an access token, a refresh token, and an ID token. These tokens will need to be added to the kubeconfig in order to authenticate to OKE. So, well, how do we do that? As I shared before, there's a kubectl command where you can set the credentials. Let me go ahead and do that. So I'm going to add the refresh token, going to add the ID token. Oh, wait, let me get the client secret. Should be auth ID token equals that. And then the client secret, I will do this off screen and then show you the end result. All right. Once I set the config, I'm sharing my editor again. Let's move that to here. Then what I can do is run a kubectl auth who am I, where I explicitly set the user to my new config with the token. And I used the wrong one. Let's see. There we go. That's the right user. There we go. So here we can see that I've authenticated as this user, and this is the group I've been assigned to. Now, in for the role binding, what it should look like is this. So here I have my subject where I have kind group and then the name of the group. If you'll recall that this user is part of the /devs group, and how we were able to get OKE to determine the group membership was in our configuration here. I set the group's claim to groups. So uh, the Kubernetes RBAC authorizer will introspect the token and check for groups here. And this was only possible because I explicitly added that scope within Keycloak. All right, and I guess the one thing I didn't explicitly show you, but I did do was I changed the issuer URL to the issuer of my Keycloak realm. In this case, I changed it to Cloud Coaching. All right, so that's in essence how you connect to Keycloak, um, or sorry, connect to OKE from Keycloak um, using OIDC. Again, that was just OIDC authentication. I still haven't shown you Discovery yet, which we are running a little bit low on time. So let me jump to the next demo. Okay. The last demo I wanted to show you was how to access HashiCorp Vault using a Kubernetes service account token. So the demo is, again, very similar. I've deployed a pod in which the Kubernetes API server, or the control plane, has mounted a service account token to that pod. What I'm going to do is use the token that's mounted to that pod to log into HashiCorp Vault. And HashiCorp Vault will then go to the issuer that's specified in that token. It will grab the discovery document. That discovery document has the issuer URL as well as the URL for the key location. The issuer will return this document to HashiCorp Vault, and it will introspect that token. It will use the keys to validate the token and then grant me access. So what you have to do here is actually very, very straightforward. So I have a HashiCorp Vault running right now in inside the cluster. Again, you can do this outside the cluster. In my case, I'm running it within the cluster. All you have to do on HashiCorp Vault is create an authentication method. You enable this new authentication method. You select JWT. You select the path you want it at. I already have a this authentication method enabled, so I will go to the existing one. when you configure it, all you need here is the discovery URL. And you see this, you'll see it's a object storage bucket, and you might be asking, well, how do I get this? It's not in the console. How do I get this discovery URL? Well, all you have to do is through kubectl, you run a git dash raw OpenID configuration. This is the discovery URL for OKE, and it will tell you what the public facing URL is that you then give to the third party provider or the third party in which you're trying to access resources. So you'll see here I have issuer and then the URI for the keys. So all I did was copy this, go into Vault, paste the discovery URL. Keep in mind this is a public facing document. Save it. And now I have the valid authentication method for JWT. However, that's not all. Now I have to configure a user that can actually, access Vault using OIDC. Before I go back to the command line, all I'll be showing is how to fetch the secret. In my case, I have this secret in this mount called secret, and it just has foo. It's just some very generic data, but I'm going to show you how you access this using that Kubernetes service account token. So, all right. So how I'm going to start is I'm going to exec into the pod that has my CLI. There we go. And then show you where that token is located. /var/run/secrets Kubernetes /token. So this is the token that we will be using to um, access our secrets in Vault. And well, first, before we do that, we have to actually create a role for this pod essentially. So I'm going to log into essentially an admin just to create this role. So I've logged into an admin. Now I have to create a role. I'm going to call it, actually, I'm going to call it cloud coaching. What type of role is it? Well, it should be a JWT role. What audiences should be bound? Should be API. What is the user claim? In this case, we're going to use sub. Need the subject bound to it as well. This one should be the name of the service account. In my case, I'm using a service account called Vault. What policies should it be bound to? These policies are the Vault policies, so not really that important for this case. And then, all right. So I've created that role. Now I have to actually bind this role to that token. So Vault write /JWT/ login role equals um, cloud coaching. And then the location of the token, which is what I specified earlier. Audience claim found in JVT. Must have mistyped something. Oh, yes. My bad. Okay. So now I've created, um, or now, sorry. Now I've logged into this user using that token. So just to verify, it, it has given me the vault token. So we'll do vault login. Then I will type that or copy and paste that, and then it'll show me that I have access to this user. And last but not least, how can I access this user? Let's, I didn't give them access to that. I did give them access to, which one did I give them access to? Cubbyhole/secret. All right. That's great. All right. I think I made maybe one small error in here, perhaps, with assigning it to the right policy. Let me see. In any case, I know I am running low on time, so let me see if I have cubbyhole/secret/foo. Okay. In any case, I know we are running out of time. I don't want to keep you all waiting. I do have somewhere a working example of this, but the problem isn't with the authenticating, it's with I messed up my policy somewhere when I was recreating this. So I do deeply apologize for that. But once I figure out this policy, this will work and I can actually see the secrets. It's just the user that I've associated with it can't see it. So um, hopefully through my fumbling, you all could see the value at least in using OpenID Connect to both authenticate to a Kubernetes cluster as well as use Kubernetes service accounts to access third-party resources. So again, huge thanks to all of you for joining us